into the scatter plot, right, to see what is the nature of the data. This is a good habit if you do all the time. Look into the relationship first and then see what would be the best to do. So strength on vertical and ratio on horizontal. So we'll see scatter plot like this one, which is not really very far from a straight line to the data. Okay, we will do that first, and then look into what can we do. What other options I have from here is a little bit concave downward here. Maybe a second order model be appreciated, maybe. So there are two options that we have in it. Another thing is that maybe this part of data from the beginning to 70, that point, indicates a straight line up to here for this part of the data, and then immediately the slope change to be more decreasing for the other set of the data. Right? So the third option may be Peice Wise regression. So what we do, first we fit simple linear regression, then we fit a second order regression model, third we fit the Peice Wise regression. What we do, we make a table. In that table, we bring some information about the models that we discussed, right? Like R-square adjusted, like the normality assumption, the constancy of variance information. Okay, these are important points. Or influential points if there is any, right? So let's start with the make a table and then fill that table. Here is the model. So first order model, then second order, then Peice Wise. Okay, so first of all, R-square adjusted. Then we look into that's residual. And then we look into the normality. Variance. So that explains the percentage of variability. That one for prediction is good. The smaller the better. That is the assumption of normality and the constancy of variance. So there may be some other criteria. I just want to give you an idea that how to compare the models, right? So let's do this one. First thing is so by the way, this column X2, if you look at the data, if you look at the scatter plot and result, you see that 70 on the ratio is the point that the slope is changed, right? So what you see here as the X2 is any number below 70 is coded 0, and any number above 70 is coded 1. So for us, K here is 70, right? So this is two lines continuous, right? Because the graph shows that they are continuous. This is not a discontinuous line. Do you understand from graph, everybody? See? Here is continuous. There is no gap between clusters of points, right? So this is X2 already done. Then that X2 star is the second part of the model. you know, if you want to do it, you can do, but this is already done. So two straight lines continuous. This part is called the x star, right? Means x1 minus 70 multiplied by x2 is called x star. All right. So everything is done. So we don't need to do this. But you know that how to do this part, right? You introduce a new column and calculate this bracket multiplied by x2 as the new explanatory variable. Otherwise, you cannot fit a multiple regression. So, all right. So analyze regression. So strength is independent and the ratio over here. So I want the press. So let's do the influential here for getting the press, right? Press residual is now in the output unless you indicate in the model. You remember that in the model before finishing this statement. We type in the So, first order model R squared adjusted is reported as 0.8783. And the press residual is okay. Predicted residual sum of the scores here. 3.73, 3.7395. Normality of this model based on this curve is a little bit awkward, right? Histogram says no. The kernel comparison kernel with the normal say no. And we can look into the QQ plot, say absolutely no, right? So normality is violated. Do you agree, everybody? Do you have the same graph like this? Yes. Normality violated. So that can be referred to as histogram, okay, kernel with normal comparison, QQ plot, and there is another one. This one is very obvious, right skewed distribution, right? High skewed, right skewed, sorry. So, yeah, that is this. What else I need? Constancy of variance is coming from residual versus predicted value. So, this is again violated because we have negative, positive, and negative, right? So, there is a trend. Okay, so constancy of variance again violated. There is a trend. There is some kind of trend that we have negative, positive, negative. That is cluster, right? So it means that we cannot say that we have constancy of variance. And also you see a trend. You can refer to a curvature concave downward, right? So it's not scattered around the zero randomly, right? At random. Okay, are you happy with the result from this first order, everybody? And if you look at unusual observations, what do you say then? Do you see any unusual observations? So you have one outlier based on R student, right? This point. And you have, again, one outlier based on the Cook's distance, right? Influential point. This is influential point. And that is exactly the same observation. And What else? Here you have VF feeds. So you have one influential observation on the fitted value on y hat, right? And what about VF betas? Again, you have one observation in each one, right? So it seems that there is one outlier, and that outlier is influential, right? On estimation of data, on estimation of the model, on prediction of the response variable. So let's write this one as unusual observation. One point outlier plus point on data hat, model, and y hat. Right. On individual beta, on whole beta, on the model, on y hat, you know that each one of those graphs refer to one aspect of influential point. So remember that if you want to write any report, you should clearly say that, okay, this point is influential on what? On beta 1, on beta 2, on beta 3, on y hat, right? So that's it. Now let's do the second order. The second order, we need another column, right? So let's produce another column, which is the, what is that? We'll say x1 squared, right? So x1 squared, x1. And that is equal to, so ratio to 2, right? So we produce another column for the square of the exponent. And now with the regression, what the same dependent variable exponent, and then ratio, and the square of the ratio, right? And also don't forget to do encoding for crest. So here we are. Okay. Honor score adjusted increased to 92.35. So 92.5%. So it's consistent with that at 49.55. First as usual. First as usual is okay, it's decreased to 2.82. So decreased to 2.82, 660. Normality, now, okay, comparison of kernel is better. Still, histogram is showing leftward skewness. Right? Now, the residual, the QQ plot, still has some problem with normality. And you see that now the box plot shows leftward skewness, right? So you see this one leftward skewness. This is consistent with the histogram, more histogram on the left of the center, right? So it means that left part is curious. So you have normality violated. But in another way, that the other one, the first one was right word, this one is left word. But anyway, this is why I. So now the residual versus predicted value is better. Is that right? Is this better? Is much better than the previous one because you have some positive, negative, and in this range. So I can say that is much better than first order model. Is not seriously violated. It is not seriously violated. Unusual observation, right? So here is two unusual observations based on the systems. One is marginal. You see this one is marginal, but the other one is very obvious one. And now, based on this graph, you have one outlier, okay, and then you have one leverage, one outlier. You have one leverage, this one, and then you have one outlier and leverage, right? So it means that with a second order model, we have more concern about unusual observations. Okay. And let's have a look at the other points. So yes, here is the same thing, TF beats, two marginal and one obvious. And for these you see 1, 1, 1. So the effect on individual beta is not changed. The effect on individual beta is not changed. But the effect on beats is changed. We have two marginal, two more influential observations. Those are marginal. You can ignore them, but this one is obviously influential. So I can write from here that one obvious outlier that is influential. On, I leave this one for you to fill in later, right? On what? You look into the graphs, okay, DF beta, DF beat, and then you look into the hood systems. You see that that point is influential on everything on the model. So to me, between these two, they are the same thing because the 2 points are marginal, right? It's almost on the line. And then compare these two, I am in favor of this model, right? Instead of that one. Regarding normality, no change, right? So if I want to perform significance test, both of them are some kind of violation, right? So testing hypotheses about both models are not good, right? From the point of prediction, this one is better, right? The second order model is better because the press is much less than the press from here. Remember that you can calculate the R-squared prediction, but that R-squared prediction will tell you the same thing as they are saying, right? Because it's nothing but 1 minus this number divided by total variability, right? So the total variability is the same thing because you have one response variable for both of them. So you can discuss press instead of the R-squared prediction if it's not specific. And R-squared adjusted is this one is much better. So this model can explain up to 92%, 93% variability of the strength by just the ratio, right? And the square of the ratio. So altogether, if I combine everything together, this one is preferred, right? The second order model. Right. Now, what we do the piecewise regression, right? So the piecewise regression is the regression of the strength on the ratio, right? And if you look at the model that we selected, so I don't want to write the model again. Look at page 470. So there are three models introduced there. Two straight line continuous, right? The first one. So that is x1 and x star, right? So this is the response variable strength. Ratio is one variable, and the other variable is just x2, x star, right? This one. Okay, let's do that. Analyze regression. And remember that when you want to report, you have to write the model, right? You should indicate K, and now K here is almost clear to us that how much was K on graph, remember? Yeah. So, strength, then ratio, and x2 star. Don't forget that you shouldn't bring x2 here, right? That is for 3 lines, right? This is for 2 lines. That's important point. Okay? So now let's go to the code for test. Okay. So now we have the piecewise auto score adjustment 0.9303. It's even better than the second order model. Right? And the pressure is 2.68. 2.68. Still better than, the second order. 6 and 3. But now you see the benefit of the piecewise regression. Right? And look into the normality. I think normality is very cold, right? Now we have better, and then the future plot is changing a lot. Histogram is here, so still normality is violated, right? Because you have here curvature. So what happened to the curve here? So the histogram is saying that this is skewed distribution. Right, of course. The kernel density says that this is skewed. If you look at this curve, the yellow one, right? This is skewed to the left. So normality is violated. So constancy of variance. Constancy of variance. I think this is good. This is not. This is much better than even the second one. What do you think? So I can say here that constancy of variance obtained. No serious concern about constancy of variance. About the influential point is that you have 1 point in books, you have 2 points in our student, okay, now here you have 1 outlier, and you have 1 outlier and leverage. So still one observation is behaving very bad. So here is the feats, that observation, this is the one that we should catch it. Which observation is that? Number 10, 11, and 12, right? The observation number 12, this one. Okay, so this one has this trend 1.13. Oh, okay. 1.2 is the minimum strength that we have, right? The other one is smaller. 1.13 and 85. What the specification this observation has is so important. Do you understand this for me? Number 12 observation. Was it number 12? I'm sorry. Okay, so
highest ratio.
yeah, highest ratio, yeah. But this one is, yes, number 10, 11, 12. I just want to be sure that you are looking into it right now. So,
What is the space between
yeah.
a ratio of 82 at 0.76 and a ratio of 85 at 1.12?
Say again, please.
So with the ratio of 82,
Okay, so wait a minute. Please.
observation 7
Okay,
with 0.76 strength.
okay.
Observation at 85%, 1.13. That's a huge jump.
You jump 82 to it should be lower. Yeah. So that is the point. Good. Good. So that is the reason that we see this observation is a little bit awkward, right? But this is what we have. We believe that there is nothing wrong with typing. Maybe we don't know because this is the only data we have. We cannot check it, right? So one possibility is just a bad record, or if the record is correct, therefore, yeah, this is the observation. So all right. So we have again one observation. Is outlier and regression. Okay. So conclusion. Want to make conclusion? Purpose of regression is prediction. You want to have the ratio and predict the strength. Which model do you prefer? Based on the presence model. The smaller the better, right? So it appears that the Peice Wise regression is better, right? Which model explains more variability of the response variable here for this trend? Again, this model, right? And then which model is more adequate regarding normality and constancy of variance? Okay, this is violated everywhere, so this is better. Okay, this is a question mark here that we speak about this later. And then about the unusual observation, there is one unusual observation show up in all the models. So from this analysis, we pick the Peice Wise model, and from here to get the normality, we use transformation on that, right? We try to do something for normality. And that could be a box transformation, right? To fix the violation of norm. And who knows? Perhaps if we do box transformation on Y, then that outlier eliminated, right? So you see, the research and the work is continued to fix a good model, still we are, you know, we have concern about normality, but that is what you learn, and you can continue to get the best model. All right, so this is the reason that we need to understand some new methods other than the second order model. You see the difference between the press and R-square adjusted here, right? Okay, any comment, any question about?
We can solve for K. Really solve for the actual point of reflection in the P-plus regression.
No, we assume it.
If you solve for K, I want to do a P off and solve observations on
What do you mean if we solve for K?
if we found where with this continuity, we found where the slope changes, we may discover that the 12 observation is right on that boundary condition. That's a boundary condition.
So you mean that this 70 that we identified here, if this one is changed, then you think that then it is possible that the outlier
We may be sitting on right at the cusp of that change.
But what you said, it was 85, right?
Right.
So it's not on the boundary here. It's here. Ratio is here. So it is not around 70.
Those all the way to the right.
Yeah, so it is not on the boundary. But I think you referred to a good point, that the scatter plot suggests that I take 70, but that is not a must. You know, you can change that one, 70, to maybe another number, right? Say 75 or 65 or 62, 72. Then that is just, a research to see which K is better to get, better R-square adjusted, pressed, or normality and so on. But I don't think that that point can, for this specific problem, change anything. Yeah, at the end here.
Another.
Yeah, of course, this is we assume that it is continuous, right? So we are not here thinking about discontinuity. This is what we consider that this model is continuous.
So we have a boundary, we do have one boundary condition, which is not to suggest that we're not going to accept any negative boundary condition.
Any other comment? Right. Now we practice on, read the scores, page 471. This data set is a different data set, okay? So we think about, we try to do the same thing. So could you please just make the same table here for this practice on your paper, and then we try to fill that table. But first of all, we look into this scatter plot. So this is the scatter plot. First of all, we should decide if we want to do piecewise regression or not. If we want to do piecewise regression, what kind of piecewise regression? Continuous, discrete, 2 lines, 3 lines? What do you think about this guy? So this graph, if I just think about a straight line, then the points are very far from the straight line. So it's not really good idea. But if I think about a straight line here in the middle of the points, like that, then another regression cannot start from this point, right? The other regression starts from this point, right? So that's kind of discontinuous, right? All right, so which model are you using? Then in page 470, choose the model and write it on your paper. Identify the model that you want to use. There's a straight line, discontinuous, the last model, right? That is the third one in page 470. This is the Peice Wise regression. So, write 3 models. So, call model 1 as the first order model, please. So, model 1 is EY equal to beta 0 plus beta 1H. This is the first order model, the score versus H. The second one would be EY equal to beta 0 plus beta 1H plus beta 2H squared. Because one thing that you can think about this data is a model which is second order model complete apart. So the second order model is beta 0 plus beta 1H plus beta 2H squared, right? The third model then is the Peice Wise number 1, number 2, number 3. So that would be number 1, number 2, and number 3. Now you want to think about this one. Before you start working on the Peice Wise, have a look please here. I want to introduce some columns to you. So age is the age that you have, okay? The reader score is this one. Then x2 is the dummy variable, is the indicator variable, and that indicator variable is based on this graph. And which number is suggested here? 15, right? So you can say that x2 is equal to 1 if age is greater than 14, right? And equal to 0 if age is less than or equal to 14. So that is what you see here. You may think about 15, okay? But this is what the data refers to. So that is the indicator variable here. So age 14 is age minus 14. Okay? You see age 14 here is actually age minus 14. Means 14 subtracted from age. Because you want to make your model, right? If you look at the formula, you see you have x1 minus k, right? So this is actually x1 minus k. K is 14. And x14, age 14, x2 is just the interaction between x2 and age minus 14. That is the last term. This is the one before the last term of your model. x1 minus k times x2, right? So you don't need to do calculation for this data. So all the columns are here. You just need to pick the right one in the model. So pick the 3 models. But you need to have age score, right? Because age score is not here. And complete this table, then we discuss about it. Okay, I'm walking around. If you have any question, ask. Have you got the sign in today?
Second one was better, yeah?
Hmm?
Second one was better. In turn, if you look at the graphs,
Yeah.
the constancy.
So I think it's time to discuss this one. So first of all, look into the R score adjusted. So how much did you get from the first order? 0.68 something? Yes? And then how much you get for the second order? It's 0.70 something, right? And for the Peice Wise, you get 0.71 something, right? So a little bit more in Peice Wise, right? And the press residual, what do you have? Press residual. Which one is smaller? This one, the Peice Wise one, is much smaller, right? Okay. So when you look into the normality, what is going on?
This is likely skewed back to second instead of
I agree with you because I saw on other computers, right? So the first one is a little bit skewed, but not the other two, right? Okay. And therefore, from the point of normality, we are not in favor of the first model if we have the second and the Peice Wise, right? And from the point of constancy of variance, what do you have?
Second one was the best.
Pardon me?
Second one was the best.
You are saying the second model is the best. What do you have the others?
Contrary back in the first instance, the concentrated
In the first one?
yeah,
Can I see the first one, please? Just 1 second, because this is important. Everybody can look into the first order model, predicted value versus. Oh, okay. So this is absolutely a trend. So yes, the variability, the constancy of variance is kind of violated. And then the second one, much better, much better. No problem with second order model. And then,
Third one is again a bit.
and for the Peice Wise,
You can see significantly.
that's okay. No, no. I guess that with the second order model and the Peice Wise regression, constancy of variance is okay. So Now go to the unusual observation. I think you have several unusual observations in this one, right? In all of them, right? So, conclusion about everything we say, from the point of prediction, Peice Wise is better. From the point of explaining the variability, Peice Wise is better, a little bit better than the second, but they are almost the same. From the point of normality, the first order model is not recommended, but the second and the Peice Wise, okay? And altogether we can say Peice Wise still is better than the others, right? So it works today for us to study another type of regression model, Peice Wise regression model, right? So what I recommend